Thank you very much, Rose. Thank you for inviting me and giving me the opportunity to present to you today. I'm colleagues with two of the presenters you saw yesterday, Salman Nazir and Seaman. So I come from the Department of Maritime Operations, and our context is very much maritime operations. Today I'm going to discuss, as the title alludes to, learning and motivation in XR, but a bit more specifically in the professional context. And I'll talk a little bit about that and go through the results of the literature review that we performed this year or published this year, which is on generic VR use and effectiveness across professional training. And then I'll get into some more of the details of the studies coming out of our lab related to XR and learning and motivation. And depending on how the time goes in terms of this 45-minute slot, correct? Yeah. I'll try to cover some of the AR projects we're doing. So this is going to be a VR-specific lecture for the most part. So the context, as you probably got a flavor of yesterday, is the maritime domain. And the maritime domain is a generic descriptor of things that happen on or under the water from an operations perspective, whether we're talking about oil and gas development, of course, fishing, fish farming, offshore wind, or ferry services and the like. I'll discuss learning and motivation through the different perspectives I take within the projects. That is the educational and training perspective. The operations perspective, as you can imagine, is quite important when you put it into a context like maritime operations. And design. And I'll talk through some of the design projects and design applications that we use, and that actually kind of builds quite nicely on Karen's talk with affordances and some of our goals or perhaps our what we strive to accomplish with user-centered design and some of our maritime design projects. I do want to make that clear distinction between professional education and training and education from, for example, a childhood cohort, grade school pedagogy, development, and research. Because it is quite different, and we use quite different bodies of research. And even though perhaps the theories might be similar or the same, in its application is quite different. So we're very much interested in on-the-job experience, certainly in our perspective, simulations, whether it's basic role-playing or more computer-based advanced simulators, practical exercises, and of course, classroom or online lecturing as well. And it is important to differentiate between these two. I'm going to use quite a popular model many of you might be familiar with, the Krager et al., in terms of theories of learning, or how to break down, I suppose, if you can call different components of learning. There's cognitive outcomes, skill-based outcomes, and effective outcomes. And I'll cover most of these today and focus a little bit more on motivational. Cognitive outcomes, verbal knowledge, knowledge organization, cognitive strategies, which is usually researched or collected through things like the standardized test or the test that we're all familiar with. Skill-based outcomes deal with role play, deal with simulations, and effective outcomes, things like motivation, things like self-efficacy, and these are typically self-reported outcomes. And I'll show you some ways that we operationalize these within our research. So, educating seafarers, we go back several decades, certainly 100 plus years ago. It is about on-the-job training. It is about on-the-job, real-world experience on board ships, in situ, in context. Throughout the 20th century, is it okay if I kind of come outside the microphone? I'm loud enough? I feel very...
Actually, no, because we're recording you, so we won't hear you if you're not there. Sorry.
Or I could walk around like this.
That's not funny.
I won't. You know, speaking in front of people, it's like I have to remember how to do this when it's not a Zoom screen. Okay, throughout the 20th century, it became more formalized, it became more codified, and this form of on-the-job training was codified a lot more through international conventions, through more formalized education, classroom-based, theory and knowledge-based. Certainly that supplemented on-the-job training at sea. And then when we move into the 1970s and the 1980s, into the 1990s, computer-based simulation began to get quite popular and quite attractive from an educational perspective. And when we talk about maritime education and training, well, we're really talking about these three major components: on the job, classroom, and then simulation, activity-based training. And there was a time, I'm sure there are many examples throughout the world, where seafaring educational facilities owned ships, and they didn't have simulators, so their practice was going on board a ship and learning in that perspective, literally a university or a educational facility being a ship owner. What we've been working on at the Department of Maritime Operations since 2016, 2017, through Inno Training being the first project that Salman Nazir has been leading, is how VR can or cannot fit into seafarer training. And particularly of interest is within this larger context as a tool. I use the word tool a lot. I use the word toolbox a lot. And it's something I'm most interested in terms of how can this particular tool be integrated for the better within the learning objectives that we have for the current seafarers and also future needs, if you will. So this is a picture of a pretty typical traditional simulator offerings. And it can move to your institutional trophies, I like to call them, the full mission simulators that get shown off a lot and also used quite a bit, but also down to the lowly desktop trainer. And what you don't see in this is a VR headset, and it's slowly creeping in to different educational institutions, seafarer training institutions throughout the world, but not in any mass way at the moment. It's very much pilot projects and single cases, single case studies and uses. So why VR? I'm not going to dwell on this because it's likely been beaten to death either today and certainly all of you coming at this with even a superficial understanding of virtual reality. Immersion, increased presence, increased sense of being there, which arguably can be achieved, particularly with some of these one-to-one replicas of a ship's bridge, for example, or ship's engine room. What is also attained with those traditional simulators is this ability to have controlled, repeatable, safe, and I use the word relatively inexpensive. And we've discussed in the iMerse group previously, there's a financial barrier with entering the XR marketplace. It's expensive, and perhaps only a few institutions or individuals may be able to afford such a technology. If you compare it to where the maritime domain's coming from, we like to discuss it, or I certainly like to look at it from the exact opposite perspective. It's actually the ability to break down barriers and enter new markets. I'm not a business person, so I use that word quite loosely. Educational markets for institutions, for countries, for companies that might not be able to afford some of the higher end simulators. So I make the argument that actually it can help break down these barriers. And of course, users, whether we're talking maritime or non-maritime, can navigate, explore, manipulate, inspect objects, et cetera, as you're all aware. And we take a simulator, a VR simulator we've been using in our project. We did some data collection on this 2 or 3 years ago. This is a hotel area of a ship. These are cabins. So, as you can imagine, we want to do fire training or search and rescue training in a ship, which I've seen done once in real life, where they actually set off smoke bombs in an engine room operating at a ship at sea for training purposes. Only once, but you can imagine, not that it's expensive, but it's time consuming and it's maybe a bit messy and a bit inconvenient, but okay, we're in the virtual world, we can set up smoke, we can set up different scenarios and act through them, we can role play in terms of identifying fire or identifying and finding personnel. And of course, this is safer. Of course, this is repeatable. And depending on the level of intensity or buy-in perhaps from your user, it could be quite a traumatic experience depending on the particular situation. If we're talking about search and rescue or evacuation, which is all standard training within that's required for being at sea. Here we have a screenshot of another simulator developed in the InnoTraining project that was actually used with Simon's master's project. And this is bringing the students who normally would get lectures in the classroom and desktop-based simulations. Well, now they can walk through a 2 or 3 story engine room and actually get first-person perspective, and be it perhaps low fidelity, we could argue, or perhaps the interaction is not one-to-one, but it's giving them the experience of inspecting equipment and actually performing some tasks within a piece of equipment. And I want to mirror that against what we've got today and think back to the reduced access or the increased access, reduced barrier discussion that I want to make a theme in this. One thing that came out of Corona is obviously distributed learning, and particularly a focus on cloud-based simulation. And I want to highlight the PhD work of Simon and his endeavors, particularly within Work Package 1. And this is a focus certainly of simulation companies. What is possibly part of that is virtual reality. We have some experience trying to deploy this in class with these individual systems across 5, 10, 15, 20 students. And it is very difficult when we're talking about single-use simulations or simulators. So perhaps that is better for the application of distributed configurations. And I look at this as that balance. And I make this argument with the PhD students within our group and researchers that we've been very focused, as I'll show you some of the research and results that we've had, on the effectiveness of deploying VR for training and the learning outcomes. What's the effectiveness of the learning within VR versus another solution? Classroom-based, desktop-based, full mission-based, maybe transfer of training to the real world. Versus this concept or this argument of, well, maybe it's not as good or maybe it's not better, but perhaps it reduces barriers. So it's another option, or it's this concept of increasing access for students, whether more students get to use it or the same amount of students get to use it more. And what's that effect on overall learning within a program or within a profession? We've discussed this at length within an article published a few years ago in terms of how our training works at the department and within the industry, really. We have our bachelor's and master's students, and they get certified and perhaps will go to sea, but we also have professionals that have to travel. And how can this be more effectively distributed? Whether we're talking about cloud-based simulation, but cloud-based simulation in the desktop form, in its current form, isn't really offering that immersive simulator. So what role can virtual reality play in that? We also use this in design projects. We talk a lot about participatory design, about inclusivity of design. And for us, that means getting the end users involved in the control of their work environment and the control of their work in terms of planning. So we're using particularly VR now as of last spring to bring seafarers on board ships and distribute it around the country to have a say within their company on different development projects for ships that perhaps they'll eventually be working on. In the olden days, as in a year and a half ago, we basically relied on very expensive, very resource-intensive methods for extracting end-user data. Whether we're talking about field studies, whether we're talking about focus groups with the people that were either paid to be there or could show up at that particular time and place because of their schedule or resources, or because they were affiliated with a particular company. And we run through design processes, design sketching, focus groups, and in some cases run various simulations. We move that to cloud-based, Zoom, Miro boards, to run the same methods, and then began doing this in 3D VR. Here we have a ship's bridge, and we have two avatars plus me, where we're distributed between Oslo and Skien, and speaking to each other through audio and making notes and lines and inserting word text throughout an environment, and trying to basically talk through different design solutions and design problems through VR. It's certainly not perfect, but we're collecting quite a bit of use data in terms of how users actually interact and see value in this. Here we're down in the accommodation area. Furthermore, we have this real-world screen capture where we could be live, kind of bridge this uncanny valley. Here we have our designer Jesper, that is projected real-time within a ship's bridge to kind of, again, break down that uncanny valley and have a little bit more interaction, at least with the viewer. Not that he is interacting with any of this virtual scene, but rather that he can talk and explain and get feedback on different aspects of an environment. And that also can certainly be applied over to the training context. We've discussed this in terms of assessment. If we have a trainer here explaining a particular equipment or operation or task. I want to shift gears now to a systematic literature review, which goes a bit more general, outside the maritime domain, and looks at VR use and effectiveness for professional training. And this was led by what is he now, a third year, in his final year of his PhD, supervised by Salman Nazir and myself, Satya Kumar. And we wanted to ask these particular research questions in terms of what are the known benefits, effectiveness, and limitations of VR for professional training. Again, making that distinction, professional training. How VR is adopted in professional training setups, and what methodologies are used for assessing the training of outcome effectiveness of VR-based training. So also with that interest in methodology, what are the current methodologies being used to assess VR effectiveness? Here are some of the criteria. If you read the full publication, there's more specific inclusion-exclusion criteria. And our search string, we ended up with 60 papers out of, I think the initial 15,000? Yeah. And our population. But this is some of the outcomes, and I think this might be interesting to many of you in terms of mapping the areas where research is being done. So you see some of the hotspots in industrial training, typically assembly lines, maintenance tasks, safety critical operations. And here we have safety and emergency preparedness, like wayfinding, for example, and search and rescue type applications. What was surprising to me is the healthcare side and VR, that it was only 6. We looked to healthcare quite a lot. In the maritime domain, we looked to other domains quite a lot, particularly aviation, aerospace, space, and healthcare, to base our theories on, to base our models on. So it was actually quite surprising to see that 6 popped up. I have some ideas on that, but perhaps also it was the search string used. But here you see a general plot of where or how and where VR is being used. In industrial training is particularly what we're interested in, so we focused on that in terms of subcategories: assembly tasks, maintenance tasks made up the bulk, visual inspection, procedural training, which is Siemens' master's thesis was on, spatial memory, and the types of skills trained. Here we see a huge proportion being cognitive skills, memory, procedural, technical, and spatial knowledge. As you can imagine, when we're talking about increased immersion of virtual reality. Well, the spatial knowledge or spatial knowledge acquisition can be quite valuable. And this is all very interesting, actually, when developing VR research, a research program, to know where the hotspots are, what may not be so explored, and also the different areas where it's being utilized in. So here's what would you say, an overview, a splash, highlights of the SLR results. Out of the 60, again, taking some highlights: cognitive skills, spatial memory, learning, remembering procedures, and psychomotor skills were shown some positive strengths there. Increases in trainees' confidence, increases in enhancing skill retention, increases in performance. This also brings up a hint of publication bias, perhaps, which I'm always happy to discuss and debate. But we must talk about some caveats. We must talk about some of the issues that have also popped up in the literature. There's quite a bit of conflicting evidence with the benefits or no benefits at all. Lack of follow-up studies, certainly. Lack of experimental robustness in terms of sample size was discussed earlier today. In terms of sample profile, are they students? Is it the weird sampling that I'm sure most of us are familiar with? Or using white middle class American college students versus professionals, for example. I wanted to also compare this to some of the research that's come out of our lab, specifically related to learning and motivation. We have the references there because I would love to spend 10 minutes on each, but I won't. Increased accuracy of memory, higher accuracy of declarative knowledge. Incidental memory recall was higher. So incidental memory is when you're asked about an environment, objects or profiles of an environment that are not the focus of the particular scenario or task. So if I were to ask one of you tonight, I call you up and I say, what is the color of the curtains on the wall? Or what is the color of what material was the sidewalls made out of? You're not really focusing on that throughout the day. We ran an experiment similar to that, these types of questions, with deploying searching tasks. And in the VR scenario, compared to the desktop scenario, participants were able to recall those types of what perhaps we call them secondary objects to a higher degree. Higher motivation and engagement levels in VR, constantly, over and over and over again. And I'm going to come back to this in terms of what I label as the wow factor and what effects that has on the data. Consistently higher motivation and engagement levels. More favorable user experiences, higher stimulation if we go to the subcategories of our data, higher stimulation, attractiveness, novelty, higher perceived immersion and realism in VR, as would be expected if we believe the hype and the abilities of VR and that ergocentric perspective that it enables us. Greater loss of time perception accuracy in VR compared to the desktop equivalent, which is quite a fun study. Technology acceptance among students for VR is very high, generally. Perhaps that is mirrored with motivation and engagement. And we have a spattering of lower performance in searching of VR tasks. If I can sum up 3-4 years of VR studies in our lab, it would be user engagement, user motivation is very high in VR. Learning outcomes, mixed. Sometimes the studies are showing, yes, VR is a more effective way to train. And then many times it is no difference found, significant or otherwise. And I wanted to give a flavor of the types of experimental designs because we talked about control groups at lunch and it comes up within some IMERS meetings and certainly our labs meetings. We want to compare this tool against other tools or other solutions for delivering training. And optimizing the learning outcome. So we come back to the issue of control. Well, what is our control group exactly? So we'll have this experimental group that will use VR. And what is our control? Well, it could be a different type of simulator. It could be a different way to learn. It could be a textbook. It could be a lecture or a series of lectures. It could be the real thing on board the ship, the gold standard, although one has less control over the real world. Typically, our control is, as I mentioned, desktop. We have a full mission study going on right now, being collected. And we are dying for the transfer of training study and studies. So that's something Seaman and I certainly talk about in terms of what are we actually comparing against? Well, we're comparing against the other tools in our toolbox that we currently have and that we currently have experience with. And this embodies what I just mentioned in terms of higher motivation, higher satisfaction reported from students, and learning outcomes were almost exactly the same across two groups. And it was really great master's thesis performed by Chris Hubert that he graduated this spring, where he looked at very simple, in terms of, I shouldn't say simple, very compartmentalized training goal, and to learn the different types of, radio equipment that exists on board a ship. And instead of either learning about it through lectures and or holding them in your hand while you're in class for the X number of minutes or hours a day, let's implant them within a real working environment where a student can go to different areas of a ship where the equipment would actually be held, open up a file, and learn about the particular piece of equipment. This is performed with a 3D 360-degree camera. Nothing interactive in here other than having the experience, kind of like a Google Earth experience. So I like to ask this a lot. What's the wow factor effect? Because we're getting it an awful lot in our studies. And I doubt it quite a bit. We're trying to employ more longitudinal studies. And longitudinal is a sliding scale. Longitudinal could be 2 weeks, 4 weeks, 1 semester, 1 year, 1 degree program, 10 years, however you define it. Because I really want to know more about this engagement, this motivational aspect on a longer term scale. Because we're getting students that, first of all, was talked about this morning, will volunteer for a VR study. So there's already a bias there because you're probably getting people that are interested in technology or at least open enough to try something new. So you're already taking a subsection of a more general population. So what is the effect, or what are the changes over time? Because from our perspective in the Department of Maritime Operations, we're looking at putting this in an educational program amongst other tools, amongst other courses, amongst other learning outcomes. So how does it work within the larger scope of a program? And we're just not sure, actually. At this point, our focus has been mainly on single-use experiments within a course for a particular task, for a particular research question. Very focused, as opposed to a more broader perspective, which I'm very interested to see. And I pose this because I can apply this to all sorts of things in life. Perhaps it will work similarly for XR. Perhaps it's worked for this lecture right now in terms of your motivation and or interest levels. Perhaps we're down here at this point. Maybe it started here. So I'm quite interested in that. There's also the aspect of technology acceptance, not just from the user perspective, which we focus a lot on. User in our case is the students, but actually the teachers also use it. And there's also the administrators and the companies. We need buy-in from multiple levels. So we also investigate technology acceptance and technology acceptance models. From an anecdotal perspective, this has come up several times, is this user expectations. We talk about this wow factor. And there's quite a wow factor with the ergocentric perspective and the immersion of VR. But then I also get comments is, well, the latency is a bit off and it was grainy when I try to read text, for example, and well, I might get headaches or I don't feel necessarily comfortable, or actually there's a quite steep learning curve in terms of being able to interact confidently and with fluidity with a particular VR device. And the reality is, particularly if we're going after the heavy tech market, there's an expectation here of Ultra HD, of gaming laptops. Some of our students that come in are avid gamers, and this is their expectation in some instances. It's not there yet. I mentioned people also need to learn how to use VR. So we're applying VR for learning seafaring related skills, but actually before any of that happens, you have to learn how to use this particular system. It's very different than the knowledge and the experience every single one of us has with a keyboard, with a smartphone in the last 13 years, and BlackBerry a little bit before that. We've had to learn or relearn how to use a keyboard in different ways. So we must keep an eye on that in terms of the learnability of a particular hardware and software. So will poor experiences turn off people? Whether it's the first point of contact or with moderate use, poor usability, poor interaction, latency, sickness, frustration. I've certainly had that, and I've certainly had participants that we've worked with in the lab that are just frustrated because they can't do what they want to do. And I love this quote. I heard it from a US Army psychologist at a conference. Just because you can doesn't mean you should. And that was 4 or 5 years ago now, and it's still stuck with me. And I pose this in relation to virtual reality as a tool within a larger toolbox. And I think there's amazing potential there, but how to best deploy it and for what? Question mark. And when we first got into this project, we read an awful lot about laparoscopic surgery. A lot of research, 2017, 2018, 2019, on laparoscopic surgery and the box simulator. And I think this is a very good example of, and I'm sure there are VR and AR solutions for laparoscopic surgery today, but also this simplicity of what you're trying to achieve. What are you using? What training method or technology or solution are you using? Okay, what's your outcome though? What's your ultimate goal? And I think we lose sight of that sometimes because, as I mentioned, well, we have trophies. We have technology trophies, whether it's a very fancy medical equipment or simulators for our seafarers. We have to come back to this. What's the true value for education, for training, or for whatever your goal is? And I think it's a very great example in terms of use of a more low-tech simulator. I think I have time for AR. I'm going to switch gears a bit because this is quite new and quite exciting for our research group. We have an open AR project. Most of our work has been focused on virtual reality for training or virtual reality for design. And now we're finally broadening into augmented reality. Again, in our context, the maritime context, what can it add to our operations? And here we're in ice flow, and this could be open water, it doesn't really matter, but in terms of projecting navigation-related information, whether it's no-go zones or projected versus plotted routes and different types of metrics that can be overlaid. Perhaps ship-related information, speed over ground, distance to the particular ship. I don't think that ship's 7 nautical miles away, though. But you get the point. Something might be interesting for you is where we started with this. You know, it started 2018, 2019 with paper-based development. when we go on board ships and we say, hey, what information do you need for this particular point in time, for this particular task, for this particular operation? And we stuck post-it notes around a $100 million ship and said, okay, you want speed over ground here, or you want alarms here, et cetera, et cetera. And then we began prototyping very static, we called them planks, just drawings. Take a picture of and import into the HoloLens 1 at this point. And played around with the placement. And that's where we started. We're prototyping this a lot right now in virtual reality. So the way I try to explain is we're concepting augmented reality solutions in virtual reality, mainly because from a pragmatic perspective, it's easier to program, it's easier to showcase ideas. And again, coming from the human factor side, getting user inputs within a virtual bridge, for example, as opposed to programming it and displaying them in the real world, which you see here. So we're working on this really exciting project that officially kicked off in May, and are working with basically different case studies, different cases that showcase AR for mostly single-use tasks. So there's not an envisionment of starting your shift and putting on your AR headset and spending your 6 or 8 or 12-hour watch shift, but rather for specific uses at specific times. And yesterday, unfortunately, I wasn't able to be here, but we were kind of doing this in the Oslo Fjord on board 3 ships and mapping different areas which information could be placed. And one of the things that's very interesting and very scary to me from a human factors perspective is workload and cognitive overload. Well, we have this new technology. Let's give the operator or give you more information. More information is better, right? You have more transparency of whatever it is going on around you. Well, that can lead to cognitive spikes, increases in workload, and that's when things usually go wrong. So we're looking at different options, basically, and testing them out in virtual reality in terms of what's useful and also what's safe. And here's an example of, again, if it's a bit confusing to say we concept AR and VR, but virtual environment, and this is the unnatural element. This is the prototype of AR information within the virtual world. And this is what I mean by cognitive overload. Perhaps you've seen this very funny video, I think it was put out in 2016 or 2017. I think it's called Hyper Reality if you YouTube it. 4 or 5 minute video, and it demonstrates exactly what I'm sure you're all aware of in terms of navigating a hyper-intense, hyper-information saturated world. And this is a bus. So you get information on everything. If you put that into an operational context of a power plant control room, or of an assembly line, or of an aviation pilot, or of a seafarer, that can be extremely dangerous. And there's a litany of accidents and accident investigation outcomes that show either too little workload, i.e. boredom, people falling asleep at the wheel or in the cockpit, or something like this. Maybe not like this, but high workload. Yes, so again, I come back to the toolbox. Where does XR fit within my toolbox, within your toolbox? I think it's cautious optimism. And I wasn't here for the company presentations yesterday, but I can make an assumption of how things went, and certainly the tone of today and the more, dare I say, realistic or cautiously optimistic perspective. And I think both are healthy because they're drivers. It's push and pull. Not that we're necessarily pulling as academics, but more research is needed, isn't it? So, better or worse supplement or replacement, revolution or evolution, cautious optimism. I think it's a fantastic potential, very interesting tool for our boxes, but how can we best utilize it? That remains to be seen. So there's publications you may or may not be interested in. I assume that these slides will go public somewhere online. So yeah, that's a little bit of an overview on learning and motivation, yes, in a professional context. And yeah, I'm not sure if there's any time for questions, but I didn't stick to the microphone rule very. Hello. Yes. Thank you.